Hello everyone, welcome to Amplify Learning. So this is our next addition to our JEE problem series. This is the part 3 and we have come with a JEE Advanced 2016 question from Gravitation. So the question is, a large spherical mass M is fixed at one position and two identical point masses M are kept on a line passing through the center of M. The point masses are connected by a rigid massless rod of length L, and this assembly is free to move along the line connecting them. All three masses interact only through their mutual gravitational interaction. When the point mass nearer to M is at a distance r equal to 3L from M, the tension in the rod is 0 for M equal to K M by 28. The value of K is. So here we have the diagram for our problem. So here you can see a rigid mass of mass capital M at a distance r from the nearer mass of mass small m. We have a uh, rigid rod of length L connecting it to another mass of small m, right? It is given that r is equal to 3L and we have to find out the value of K for the condition, that is we develop no tension in this rod. Now we have to form the equation for the development of tension in this rod, right? So we have tension in this rod which will be equal to, now we have to understand that tension is basically stretching, right? Stretching of the rod. So we have to understand which force on which mass will be developing tension in the rod and which mass will be developing compression. If we consider tension as whatever that is developing, if we use a sign convention and think of the forces that are developing tension as positive and the forces that will develop compression as negative, we can write an equation and equate it to 0, right? So first of all, I am considering the forces between this mass and this mass. Okay, so that will be capital G gravitational constant multiplied by capital M small m divided by the distance square of the distance between them, that is r square. This is a mutual gravitational attraction, so this will be in this direction, right? Okay, so this will be in this direction, so this will be stretching the rod, so this will be tension, that is why it is positive, right? Now g m square by l square, that is the mutual gravitation forces between these. So now this mass will be attracting this mass, so it will be pulling it like this, so it will be a compression type of force on the rod, that is why we have used negative, and it will be obviously g m square by l square, right? And now if we consider the attraction on this attraction force on this mass by this mass, that will be in this direction, it is also similarly developing compression in the rod, so that is why you have used minus. Now we have another force, that is this mass will be attracting this mass, this will also be in this direction, right? Now these arrows are not representative of the magnitude of the force, it is just representing the direction. Alright, so this mass is also attracting this mass in this direction. Now this will also develop a compressive force in this rod, so that is why we have taken as negative. Now we have the equation for the tension complete, we equate to 0 and we solve it. So we put the value of r, right? We sum this up, we get minus 2 gm square by l square. Now r is 3l, this is l, so it will be 4l, right? Now further simplifying, we take the basically LCM and we subtract this, so it will be 16 minus 9, and we have 16 into 9 which is 144 in the denominator, right? And 16 minus 9 will give us 7, right? We take this equation from take this term from the left hand side to the right hand side, right? Now we can cancel out capital G, L square, and the small m, right? So we are left with capital M and small m. And now we get the equation in that format where we need the k value, constant k value from. So we get m is equal to 7m by 288, which comparing to our given equation yields that k is equal to 7. So this was the solution. If you want further more solutions of different JEE Advanced and JEE Main questions, we have other videos in our channel and we'll be bringing more soon. So stay tuned. Thanks for watching. Like and subscribe.
Thank you for watching. Do leave a like, and for more such educational content, subscribe.